Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at quadratic simultaneous equations. Now at A-level, when you have a quadratic simultaneous equation, what you have is this. You have one linear simultaneous equation and one quadratic simultaneous equation. And what you need to do is you need to solve either x and y or a and b or whatever your two variables are, you need to solve them. Just like you do with linear, you need to solve them here as well. Now, let's have a look. What we have when we've got quadratic simultaneous equations, so one linear and one quadratic, is we have up to two pairs of solutions. So for example, this would be a solution. X is equal to 5 and y is equal to 9 if x and y are the two things we're needing to solve. So that would be one solution, but in most cases another solution is also available and you find two solutions. Here we've got another solution. We've got, well, x doesn't have to be 5, it can also be minus 10, and in the case when x is minus 10, y is equal to 1. Those are just two examples that I pulled randomly out of thin air, but those are kind of the solutions that you're going to get. You're going to have almost two coordinates, if you like, 5 and 9, and minus 10 and 1. Those are the two solutions to simultaneous equations when you've got a quadratic involved. Okay? Now it doesn't have to be 5 and 9 and minus 10 and 1, those are just examples. So, let's have a look at the method that we need to do. You might have seen this method before, but you also might not have done, so let me work through it slowly. The first thing you need to do is you need to rearrange the linear to be x equals or y equals. If it's a nice question, you might already have it in that form, but if not, get it into x equals something and y equals something, okay? Choose x or y. You might find that rearranging to give x equals is easier than rearranging to give y equals, but just depending on the question, choose which one you want to rearrange for, okay? Once you've done that, you then want to substitute part 1 into the quadratic equation. So if you get x equals something, substitute wherever you see an x to give the rearranged equation in part 1, okay? Then once you've done that, you then want to solve that new quadratic equation because you're going to have a quadratic to start with. Then when you substitute part 1 into there, you then need to solve in part 3, you need to solve that quadratic equation. We'll look at examples in a minute. Once you've solved that, you're probably going to get two values because it's a quadratic. You might have one repeated value or you might have two different values, but you're going to have two values there that then you need to substitute into the linear to then give us the value that we didn't choose first place, so either x or y. Okay, so you could substitute, it says here linear, you could also substitute it into the quadratic one if you wanted to, but we always substitute into the linear. Okay, so rearrange for x or y, then substitute that value or that rearranged equation into the quadratic, solve that new quadratic to give either x or y, and then substitute into the linear to solve for the other quadratic equation, or the variable. Got there in the end. Okay, so let's have a look at an example. We want to solve here the simultaneous equations. You can see this is our linear, and this is our quadratic. Linear because we've only got x and y, we've got no powers of 2 or 3 or 4, and it's quadratic here because of this x squared. I'm going to call this equation 1 and that equation 2. So you can pause and have a go if you want to, and then press play and we'll work through the answer. Okay, if you paused, hopefully you've got an answer. Let's see whether it's correct. Don't worry if you struggled, let's work through it now. So, part 1, let's have a scroll back up, says rearrange the linear to be x equals or y equals. I'm going to choose x equals here because we can see all I need to do to get this linear into x equals is subtract 2x from both sides. So part 1, and in fact I'll write that down in orange, that can become x is equal to 3 minus 2y. That little arrow there just kind of says, it's an implies arrow. It says if we've got this linear equation, then x is going to be 3 minus 2y. Okay, and all I've done to get that is subtracted 2y from both sides. Then what I'm going to do, that was part 1. Part 2, what does part 2 of the method tell me? It says substitute what we found in part 1 into our quadratic equation. So let's do that. Every time I see an x, I'm going to replace it with 3 minus 2x. So I'm going to have 3 minus 2y. 3 minus 2y squared plus 3 times 3 minus 2y times y is equal to 10. Then what I'm going to do is I'm going to have, well, I'm going to have 2 brackets. I'm going to multiply them out to give me 4y squared minus 12y plus 9. And let me just double check that I have done that correctly. Let's have a look. I hope I have. Yes, I have. And then we're just going to, well, I'm going to write this as plus 3y times 3 minus 2y is equal to 10. And that might make it a little bit easier for you to distribute the 3y along the brackets. So 4y squared minus 12y plus 9 plus 9y minus 6y squared. Okay, and then I'm going to have minus 10. I can make that equal to 0. It could be equal to 10 here, but we want the quadratic to be equal to 0 so we can solve it. So I'm going to subtract minus 10 there. Okay, then once we simplify all of that, just checking that that is all correct. Yes, it is. What we're going to get is, and I'll put dot 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 because we could have some working out here. We're going to have minus 2y minus 3y minus 1 is equal to 0, because I can just do a little highlights here. Those are our y squared terms, those are our y terms, and then there we've got our constants. So that's where these terms come from. Okay, so then all I'm going to do, well, I'm going to have that as 2y squared plus 3y plus 1 by multiplying everything by minus 1. And I do that so I've got a positive constant here. And then I'm going to factorise that. Now I'm going to factorise by saying two numbers that times to give me 2 and add to give me 3. That is 1 and 2. So then we're going to have, we're going to have 2y plus 1 times 2y plus 2. And then I can simplify that second bracket by dividing by 2 to give me that. If you're unsure of factorising, I do have a video on the channel. So then I can say, right, well, 2y plus 1 is equal to 0, or y plus 1 is equal to 0. And this tells me that y is equal to minus a half, or this tells me that y is equal to minus 1. So there we go, we've got two values for y. So those are two correct values. We're going to accept them both, and then we're going to find two values for x. So solve the new quadratic equation. I should have really said that this was part 3 when we were solving it there. And then part 4, what do we need to do for part 4? Part 4 says substitute our values for 3 into the linear equation. The linear equation is actually quite simple. It's that, okay? That's our rearranged linear equation. You could substitute it into part 1 there, but substituting it into the rearranged version is much nicer. You can also substitute our values for x, or were they y? Our values for y here into the quadratic equation. It doesn't matter, but we see straight away that if we substitute into here, we do get x out straight away. So we know here that x is equal to, is it 3 minus 2y? Yes, it is. 3 minus 2y. And so when y is equal to minus a half, x will be equal to 3 minus 2 times minus a half. And then that is going to give me, well, I'm just going to check that is correct. Yes, it is. It's going to give me 3. The minus 2, or the minus and the minus will cancel, and the 2 will cancel to give me 3 plus 1, which is 4. So that tells me that x is equal to 4. But we've also got when y is equal to minus 1. And when y is equal to minus 1, x is equal to 3 times minus 2 times y, which is minus 1, and that is going to give me 5 because it's 3 plus 2. So that will give me x is equal to 5. Now I'm just going to move all of that up because what I always like to write is, hence, x is equal to 4 and y is equal to minus a half from those pair of solutions there. But we've also got these pairs of solutions, okay? X is 5 and y is minus 1. So we can write or x can be equal to 5 and y can be equal to minus 1. And we could write that as coordinates if you like, x and y like that, and 5 and minus 1. It doesn't matter, but that there is our final answer. We've found a pair of solutions and another pair of solutions that satisfy our two equations, our pair of simultaneous equations. Example 2 says solve the simultaneous equations. We've got a linear and a quadratic one again. Here we've got a quadratic for both x and y. We've got x squared and, minus y squared here. Okay, so press pause and have a go if you want to, and then we'll work through the answer. Okay, hopefully you have had a go. I'm going to pull up my solutions so I know I'm doing this correctly, and let's have a look. So the first thing I'm going to do is I'm going to rearrange equation 1. And I'm rearranging equation 1 because that is my linear equation. Here I can rearrange for x or y, and it's always the case. Sometimes there is an easier one to rearrange for, and to be honest here, there isn't really an easier one to rearrange for. I am going to rearrange for x so that I have no negatives, rearrange for y so that I have no negatives. When I add the 4x to both sides, the negatives will disappear, but it really doesn't matter. So what I'm going to do is rearrange for y, so 5y will be equal to 1 plus 4x. So y will be 1 plus 4x over 5. And I'm just going to highlight that in grey because I'm going to keep hold of that, okay? So that was part 1. All we did was just rearranged for x or y, and here we did y, okay? If you rearrange for x, don't worry. As long as you get the right solution, that's all we really care about, okay? As long as you get to the answer that you need is perfect. Okay, so we've done that. Now let's have a look. What did part 2 say? Part 2 said substitute this into the quadratic equation. So let's do that. I'm going to substitute that into the quadratic, which we called equation 2 here. There's equation 2. So let's do that. We've got y, so we're going to have x squared minus y squared, which in this case is 1 plus 4x over 5. Square that. Plus 5 times x is equal to 41. I'm then going to square top and bottom there. I'm going to have x squared minus 1 plus 4x squared over 5 squared, which is 25, plus 5x is equal to 41. Then, I'm going to get rid of this 25 on the bottom, and to do that, I'm going to multiply everything by 25. So we're going to have 25x squared minus 1 plus 4x squared plus 125x is equal to 1025. Just checking that's correct. That's what we need to do. Okay, then what I'm going to do is, I need to solve this quadratic, and what I need to do is get it in our general quadratic form. So I'm going to expand this bracket here. So to do that, I'm going to have 25x squared minus, and then let's expand the bracket. So I'm going to have 16x squared plus 8x plus 1. And then plus 125x is equal to 125. If you're unsure of how to expand this bracket, have a look at another video on my channel. I've left the brackets in here once I've expanded this double bracket because it's minus everything inside this bracket. It's minus this whole term. So we need to, when we expand, make sure we take the negative of every term, okay? Don't just take the negative of 16, because if I get rid of those brackets, that says minus 16x squared plus 8x plus 1. We don't want that. We want the negative of everything in that bracket. So what I can do is I can have 25x squared minus 16x squared minus 8x minus 1 plus 125x is equal to 1225. And then when I do a little bit of rearranging here, I'm going to get this. 9x squared plus 117x minus 1026 is equal to 0. Now, with big numbers like this, it might be able to factorise, but I don't want to factorise that in my head, definitely not. So, you can either use a quadratic formula, or you can complete the square. Again, that's a little bit tricky. I would use the quadratic formula. And when you do that, I'll put ... to show I'm missing out some steps here. You should get x is equal to 6, or x is equal to minus 19. So that is part 2. This was part 3 here because we ended up solving the quadratic there. Well, actually, we can move that down a little bit to there, and we wanted to solve that. So now we've got a value for x and a different value for x. And all we now need to do is work out our two values for y. So let's have a look. This here was our rearranged linear equation. So y, and we'll write this as part 4, y is equal to 1 plus 4x over 5. We want to work out what y is, and we've got our two values for x, so we can just substitute our x's into there for part 4. So, when x is equal to 6, y is equal to 1 plus 4 times 6 over 5, which is 1 plus 24 over 5, which is 25 over 5, which is 5. And also when x is minus 19, we've got y is equal to 1 plus 4 times minus 19, all divided by 5. And when we get that, you can do some calculation there. We get minus 15. So our pair of solutions are, we can say, hence, x is equal to 6 and y is equal to 5, or x is equal to minus 19 and y is equal to minus 15. And that is your final answer. Now, just like with linear equations, when we've got two linear equations and we want to solve them simultaneously, when you get your answer, it's really useful to put them back into either equation. Both is very, very good, and check that your answer is correct. But those are correct, so hopefully now you can find the values of x and y, or a and b, or whatever, when you've got quadratic simultaneous equations.